Dear students, today we are going to talk about few more formulas expressing the refractive index of second medium with respect to first medium. What we are going to do is we are not going to derive this formula actually, but we are just accumulating all the expressions we got to know for refractive index, and so that we have a full picture in our mind. Here you see this formula we derive from Prism, and that we shall be doing later in this chapter only, but for the time being we are just mentioning the formula which we will get it later. It is the ratio of refractive index of second medium, in fact the medium of prism material, that means if it is made of glass, we have a refractive index of glass with respect to air given by sine of A plus delta m by 2 divided by sine A by 2. What is A? A is the prism angle. Say if we have a incident ray in this direction and it is emerging out finally in this direction, then the angle by which the ray is deviated, that angle is known as angle of deviation, and the angle above the opposite to the base is prism angle. This is called base, and delta m is the angle of minimum deviation which we derive from angle of incidence, and delta graph we draw for a prism. So next is refractive index by a lens maker formula. We will derive this relation also, which is quite extensive. Here we have in terms of refractive index, in terms of radius of curvature of the first surface and the second surface of the prism, lens. We use the bifocal lens, and here R1 and R2 are the radius of curvature. Say we have a lens like this, then the radius of curvature is nothing but the radius of that sphere from whose this surface has been cut out. Similarly, we have another sphere whose part is this surface, so radius of this spherical surface is this one will be R2, and similarly this one will be R1. Well, we shall be discussing it in details, but for the time being we have in terms of focal length as well. This is the focal length of the lens, and therefore we call it lens maker formula. Next is refractive index given in terms of absolute refractive index. We have discussed it also, but I thought better to mention it once again, and we have also mentioned it in terms of the speed of light in vacuum divided by speed of light in second medium. For mu2 we have this from the basic definition of absolute refractive index, we get this C by V2, and for mu1 this is the absolute refractive index of first medium, and that will be equal to C divided by V1, where V1 is the speed of light in first medium, V2 is the speed of light in second medium. When we cancel C and reciprocate V, we get V1 by V2. So refractive index of second medium with respect to first medium is equal to speed of light in first medium divided by speed of light in second medium. This formula is very frequently used, so you must be well acquainted with it. Now next is the Cauchy's formula. It was given by Cauchy, which is in terms of certain constants and given for a given particular wavelength. So wherever we have used this relation, refractive index of second medium with respect to first medium, certainly it is different for different frequency of light used or different wavelength of light used. So because the velocity, the speed of light of different colors in a given medium are different. However, the speed of light of all colors in vacuum are same. But when the same light are passing through a medium other than vacuum, in that case the speed of different colors of light will be different. And so certainly the refractive index, their refractive index will be also different. And here also, if you see focal length of a given lens for a given color will be different. So also the angle of minimum deviation for a given color will be different. And that way you can see that everywhere if we change the wavelength, if we change the frequency of light, the refractive index of second medium with respect to first medium will also be changed, which will be different. Here A, B and C are known as Cauchy's constant, and lambda is the wavelength used for which this refractive index is obtained. That's all for today. Thank you and have a nice day.